Hello everyone! Today we're going to talk about inverse functions. With me, your presenter Janine Salvado. Helping us today for this video is our scriptwriter Juliana Ingito and video editor Camille Taytayan. So let's jump right into the video. Part 1. Identifying inverse functions. For us to be able to identify inverse function, let's establish these key ideas. Number 1. A function is only considered an inverse function only if the domain of one function can be formed on the range of the other and vice versa. Second, the assumed composition is equal to x. Finding the inverse of a function. Here are steps to follow in getting the inverse. Replace function of x with y. Make sure to replace every x with y and every y with x. Next, solve for the y. After solving for the y, denote the inverse as g of x. For you to be able to check if your answer is correct, you can apply composition of functions. Let's apply all those steps we just learned in these following equations. Question number 1. You have the given h of x equals 5 minus 9x. Find its inverse. Step 1. Rewrite h of x as y. Step 2. Replace all the x in the equation with y and vice versa. Step 3. Solve for y. Since 9y is negative, we're going to transfer it to the other side in order to make it positive. This then makes the x negative. In order to remove the 9 in y, we will divide whole equation with 9. This leaves us with y equals 5 minus x all over 9. Lastly, denote the inverse as g of x, or in this case, h inverse. Let's check if our answers is correct. First, we're going to compose h of x with the inverse. The original equation is 5 minus 9x, so we will replace the x with the inverse. This gives us the solution 5 minus 9 multiplied to the quantity of 5 minus x all over 9. Following the rule of PEMDAS or PEMDAS, we will be doing multiplication first. 9 can be cancelled, which leaves us with the equation 5 minus the quantity of 5 minus x. Following the rule of subtraction in polynomials, we need to distribute the negative sign. This gives us 5 minus 5 plus x. 5 minus 5 gives 0, which our final answer is x, making our answer for the inverse of h of x is correct. Question number 2. Given is h of x equals 1 plus 2x all over 7 plus x. Find the inverse of h. First, rewrite h of x as y. Second, replace all the x with y and vice versa. As we can see, there are 2x in the equation, so we will replace both of them with y. Third step, solve for y. We're dealing with a fraction, so we must eliminate in order to make it easier to solve. To remove the fraction, we must multiply both sides with the denominator. This gives us the equation x times the quantity of 7 plus y equals 1 plus 2y. Then, we will distribute x, which gives us 7x plus xy equals 1 plus 2y. Transfer xy to the right side of the equation, making it negative. Same as 1, transfer it to the left side, making it negative as well. We can factor out y from the equation on the right side, leaving us the quantity of 2 minus x times y. Divide both sides by 2 minus x in order to get the final answer for y, and that is our final answer. Now we will check our answer if it is correct. First, we will compose h of x with its inverse, giving us the equation as seen on the right side. Since there are 2x in the original equation, we will replace both with the inverse. Since the answer for inverse is a fraction, it is difficult to solve. So we will multiply the numerator and denominator of the whole equation with 2 minus x to cancel out the fraction. Then proceed with multiplication. Let us first focus on the numerator. Distribute 2 minus x to the equation. This gives us 2 minus x plus 2 times 7x minus 1. Let's now proceed to the denominator. After distributing 2 minus x, it will leave us with 7 times the quantity of 2 minus x plus 7x minus 1. Now it is time to simplify. After simplifying the equation, it will leave us with 13x over 13. A number divided by itself is 1, so our final answer is x. Question number 3. We have the given f of x equals 4x over 5 minus x. Find the inverse of f. Rewrite f of x as y. Replace all x with y and vice versa. Now let's solve for the y. Eliminate the fraction from the equation by multiplying the value of the denominator to both sides of the equation. This leaves us with 5x minus xy equals 4y. Transfer xy to the right side of the equation and factor out y. Divide both sides with 4 plus x. This leaves us with our final answer, which is 5x over x plus 4 or 4 plus x. Now let's check if our answer is correct. First, compose f of x with its inverse. This gives us the equation as seen. We will use the same principle as we did in question number 2 in order to eradicate the fraction and make it easier to solve. This then gives us the equation 2x over 5 times the quantity of 4 plus x minus 5x. Next step is to simplify the equation, which results 20x over 20. Then again, our final answer will be simplified to x, which makes our answer correct. Question number 4. We have the given f. Function of x is a quantity of x minus 2 to the power of 3, and let's find its inverse. Now that we're already familiar with the first 2 steps, let us proceed to solving for y. Again, the first 2 steps is you replace all x with y. Make sure to replace all the x with y. So now let us transfer 1 to the left side of the equation so that we can deal with y. In order to remove the exponent, we must apply the opposite process of it, which is getting the root. Apply it on both sides. In the equation, we can see that the quantity x minus 1 has exponent of 1/3. This is the exponential form of the radical cube root. You may write the radical or the exponential form because they're just the same. This then leaves us with y minus 2. Transfer 2 on the left side, giving us the final answer on the right. Now it's time to check our answer using composition of function. Compose function of x with its inverse, so the equation will be as shown on the right. It seems complicated, but it really isn't. First, we should follow PEMDAS rule. 2 minus 2 is 0, so we are left with the next equation. Following the rule of exponents, the exponent 3 can cancel out the 1/3 exponent, so we are left with x minus 1 plus 1. This then gives us a final answer, which is x. Therefore, our answer is correct. Question number 5. Given a of x is the 5th root of 2x plus 11. Find its inverse. First, you write a of x as y. Second, replace all the x in the equation with y and vice versa. Now let's solve for the y. First, we have to eradicate the radical in the right side of the equation. To be able to do this, we multiply both sides of the equation with the exponent 5. This then leaves us with the x to the 5th on the left and 2y plus 11 on the right side. Next, transpose 11 to the left side and divide both sides of the equation with 2, leaving us with the final answer, which is x to the power of 5 minus 11 all over 2. Now let's check if our answer is correct using the composition of function. Let's first compose a of x with its inverse. This gives us the equation on the right. First, we simplify the equation into 5th root of x to the power of 5 minus 11 plus 11. Furthermore, it can be simplified to the 5th root of x to the 5th. This then gives us the answer x, which means our answer is correct. So I hope you all understand the lesson inverse functions with the given examples we have for you, and thank you for listening. Have a great day and stay safe. Bye!